Okay, thank you, Lucas. Let's see whether the screen share works. Yes, it works. Okay, so the idea now is that we saw, or we should have seen if it would work, but let's all imagine that we saw that the training on the local laptop hardware is just way too slow and we cannot wait that long. So we need to find new solutions to train large neural networks on scale. I mean, here we only wanted to try to train the head, so the last two layers, and not even the whole transformer model. So imagine we would have tried to do that. But now I want to slowly introduce you to a solution that allows us to train networks at scale, and this is cluster computing. And we did this quick survey in the beginning, if you remember, where we asked you whether you had experience with remote server access, and some of you wrote that they have no experience at all, or quite few or quite little experience. So I want to take these quick maybe 10 minutes to show you hands-on a few concepts that you will need, so that you can start using our cluster starting today even. So the idea is that we will we already set up a small dummy cluster for you that you will be able to ship your projects for this lab or for the seminar on, and use it together with your students or your fellow students, and you will also encounter the classic problems that one will encounter there, which is resource conflicts, like everyone else wants to use the server when the deadline is due. So we will also learn about that a bit. But first you will have to be able to enter the cluster. And I want to quickly, maybe let me try this. Quickly show you a concept that we have here, and that is actually quite common in cluster computing, and this is the separation between the compute nodes.
Maybe for this you should stop your screen share, otherwise the window or the picture is quite small.
Yeah, that's not good. Let me see. Okay, here. You won't show yourself. Yeah, I won't see myself here, but I can see here whether. Yeah, you can see me. Okay, those are the compute nodes. And actually, at the moment, we just have one, which is Gamma Web 07, but there will be more to come. But the idea is that this is behind a very strong firewall. So it won't be breached from the outside. This is only accessible via VPN, and you won't get into this. But the idea is also that you don't directly run your jobs on those compute nodes, but rather on a so-called entry node, which will then schedule jobs on those compute nodes. And this will be done using a scheduler called SLURM, and this is why the whole session today and also next week is called Computing with SLURM. And now we just have to access this entry node, which is another server in our cluster sitting out somewhere, but we will have to log into this node, and we will do this using SSH. And if you remember, in the beginning, we actually asked you about your proficiency with SSH. So this will come handy right now. And actually, I will do most of the work for you, because I will now quickly demonstrate how this works. But first, have to activate the screen share again. Okay, should work now. But we can see it here.
Like when, oh, no.
No, we can, yep. Okay, so SSH is just the command that you can use to access servers. And you will all, after this lecture, when I get to it, receive emails with access credentials or a prompt to enter a password. And then you will be able to, just as I do, log in yourself. I will also give you instructions in this email. But let me here quickly demonstrate to you how this will look. So we just run the SSH command. This is the user that I created, Niklas Decker's test user. And this is the IP address of our SSH entry gateway. And I will now try to execute it, and permission denied, public key. So the lesson that you should take from here is that the password that you will have to assign to your account is not the password you will be using to access the SSH gateway, because that would be unsecure. People might breach your password, and then we would have, I don't know, someone mining Bitcoin on our network, I don't know. So the idea is that we use a public key or a key pair method to log into SSH. And I think pretty much all of you should already have heard about this in some way, but I will quickly do this with you. So the idea is that you create a public key. You provide the public key to the server owners, which is us. And we will make sure that the server recognizes you based on the public key. And you will also create a private key just for you that you keep for yourselves. And this is used to authenticate to the server. But here, I don't have it set up yet. So let's do this quickly together. Let's create a key pair, because this public and private key pair is always created together. Otherwise, it would be not possible. And I will just use test out as an output directory. Passphrase, I don't want any. I would recommend to use one, but now I just randomly created my very secret SSH key pair, and I can actually see how it looks. I will not show you my secret private key, because that's a very bad thing to do, but I can safely show you my public key, because you can't use that to do anything. But this is actually the key that I will provide. So I will copy that I will provide to the cluster to authenticate myself. And you will also have to do that. And the question is, how will you do that? And this will be done using our website. I will quickly switch over to the browser sharing. There it is. I already logged in, I guess. Need to log out again. So the idea is that on a cluster, we have a GitLab instance running where you could, can you see it? Yes. Where you could, host your projects. I don't know, host your code. This, if some of you want to write your final thesis with us, this will come in handy again. But yeah, if you log into this, you will see this login screen, and it's very important. I will also write that into the onboarding email, that you select standard here, because the university account is only linked to the LDAP of Bauhaus University, and we don't do that now. So you enter your username and password that you will give yourselves, and then you're in. And here you go to your user account, edit your user. I will also send you a direct link to this, no worries. And then here you can find your SSH keys. And this is the place where I will now add the public key that I just created. So just paste it in here. It will automatically, pass this and try to understand which format we are providing here. Give it a name, which could be the computer name that this is on, for example. Give an expiration date if you want, and then you can just add the key. And as you see, I already did this previously, so we can now go on. So please understand that there's a large difference between your GitLab password and the SSH key pair. So the GitLab password is only for GitLab, and the SSH key pair can be used to access our entry gateway. Okay, yeah, and what do we do with the private key? Well, this is depending on your system specifications or your operation system. In most cases, you will paste it into this directory, which is your local home directory /.ssh/config, but this may depend a bit on your configuration, but then it should be able to be recognized when you try to SSH into something. Okay, I will now quickly do this. I will switch over again to switch over again to our terminal environment. And here I already did it. I already typed in SSH. Well, actually, I didn't because I'm using a shortcut here, but you can log in yourself then using SSH command. And we have a terminal environment here as well. Can I actually type hostname? Yes, I can. So now we see we are on beta web 097, which is our current entry gateway. And we can already run software here, right? We can already use Python. But I will tell you why you will never want to do this in a minute. Okay, so we have a program running here. And now I'm getting tired, or I don't know, my laptop crashes and this window gets closed. I will not do it because I'll have to restart the screen share. But what happens in the end? This process gets canceled and all your data is lost. So, and on the other hand, you don't have any resources on here. This is just the SSH gateway, which is just a very small cluster node, which should not be used for any kind of computations. So don't do that. Okay, what about the first issue, this closing of programs when we close this window? Well, we can use a screen session there. So if you don't know what a screen session is, please look it up. I will quickly use one. So the idea is that we have some kind of software running in the background that handles our processes for us and keeps the window open when we are not looking. We'll give it a name. And here we are in a screen session. We can also run our program here again. Let me check. No, I have to go to Python first. Run our program here again. And now I close the screen. Well, I don't really close it. I just detach it using Command or Control A and release it and then press D. Now I'm out of this. But the screen is still running in the background, as you can see here, and I can rejoin it if I know the same name, and you can see it progressed in the background. Great. Please all make use of this and note of this. Okay, but still we are executing stuff on the entry gateway. That's not good, right? And this is where the next speech by Yannick will come in. He will tell us how to run programs on our cluster node, but at first he will tell us today how to actually ship your software in a format that the cluster nodes will understand. But to give you a bit of eye candy here, I will quickly go into the other container that I had running in the background. How I got there doesn't matter, but you can see here, we'll learn that later. If you run hostname, then you can see, I'm on Gamma Web 07. I'm on the cluster here. And now I can just run. Yes, thank you. Yeah, I also have this written down here, but I would have missed it. Yeah, and you can see NVIDIA SMI lists your GPU resources. So here we can see we have very powerful GPU resources. 4 A100s just dedicated to this lab, but you will have to share among the other students, and you will only get a 5 gigabytes slice at the beginning. But this will be sufficient for running the software that Lucas introduced to us, and I will quickly do it by the press of a button. And yeah, you will have to believe me that it's actually running in the background. But also the training time, I tested it, was like cut down to 4 minutes for one epoch. So a reasonable amount of time. And in 1 week, once we get you to run the magic command that brought me to Gamma Web 07, you will be also able to run this and explore it yourselves. Okay, thank you. I will now hand over to Yannick, who will talk about Docker